Hi all, welcome to the FEE YouTube channel all about electronics. So in this video, we will learn about the octal and the hexadecimal number systems. So as you know, the computers and the digital circuits works on the binary number system, which consists of only ones and zeros. Now these binary numbers typically requires 3 to 4 times more digits than the decimal numbers, and therefore the computer works on very large binary numbers. And in fact nowadays even a 64 bits. Binary numbers are also very common. So these numbers could be some numerical data, or it could be some memory location, or even some instruction code. So whenever a human operator or the user wants to interact with the computer, then dealing with such large binary number becomes very difficult, and in such case this octal and the hexadecimal number system is very useful. So now if you see this octal number system, then it consists of total 8 symbols, and as you know this 8 can be represented as 2 to the power 3, meaning that every 3-bit of binary number can be represented just by one octal digit. So if we have a 12-bit of binary number, then in octal number system it can be represented just by only 4 octal digits. On the other end, this hexadecimal number system is a base 16 number system, which consists of total 16 symbols. So as you know, the 16 is equal to 2 to the power 4. That means every 4-bit of binary number can be represented just by only one hexadecimal digit. So if we have a 16-bit binary number, then in the hexadecimal number system it can be represented just by only 4 hex digits. That means by using this octal or the hexadecimal number system, these interacting with the computers becomes much easier for the user or the operator. So throughout this video, we will learn the following topics. But first let's start with the octal number system. Octal number system and counting in the octal number system. So as I said, this octal number system is the base 8 number system, and it consists of total 8 symbols. So here is the list of all 8 symbols. Now if we want to count in this octal number system, then it is very similar to the decimal number system. That means once we use all the symbols for the counting in that particular number system, then we will reset that column to the 0, and we will increment the next column by 1. That means the next number will be equal to 1, 0. So once again the counting will go up to 1, 7. So once again, since we have used all the numbers in that number system, so we will reset the rightmost column to 0, and we will increment the next column by 1. That means the next number will be equal to 2, 0. And once again the counting will go up to 2, 7, and then after the next number will be equal to 3, 0. So that is how the counting is done in the octal number system. And here is the list of corresponding decimal numbers. That means the 8 in the decimal corresponds to 1, 0 in the octal number system. Likewise, the 24 in the decimal corresponds to 3, 0 in the octal number system. So later on, we will see that how to convert the octal number into the decimal equivalent number and vice versa. How we can convert this decimal number into the octal number. But first of all, let us see how to convert this octal number into the binary equivalent number. Octal to binary conversion. So here is the binary equivalent numbers corresponding to each octal digit. So to convert the octal number into the binary equivalent, we will replace each octal digit by the corresponding 3-bit binary number. So let's say we have an octal number 6573. So for the octal to binary conversion, we will replace each octal digit by the corresponding 3-bit binary number. So here the binary equivalent of the 6 is equal to 110. Likewise, the binary equivalent of the number 5 is equal to 101. Similarly, we can replace this 7 by 111. And likewise, these 3 can be replaced by 011. So now if we group all these binary numbers together, then this is the binary equivalent of the given octal number. So now let us take one more example, which also contains the fractional part. So first of all, let us write down each octal digit, and now let us replace each digit by the equivalent 3-bit binary number. So here this 1 can be replaced by 001, while the 4 can be replaced by 100. Likewise, these 5 can be replaced by 101. while the 2 can be replaced by 0, 1, 0. Then after we will have this binary point, and after this binary point these 7 can be replaced by 1, 1, 1, while the 6 can be replaced by 1, 1, 0. So while writing the overall binary equivalent number, these 2 zeros on the left can be neglected. Because these, likewise after this binary point, this rightmost 0 also does not carry any value, that means while writing the overall binary equivalent number, this 0 can also be neglected. That means this is the overall binary equivalent of the given number. So that is how we can convert any octal number into the corresponding binary equivalent number. So similarly now let's see the binary to octal conversion. Binary to octal conversion. So for the binary to octal conversion, starting from the least significant bit, we will make the group of 3 binary digits, and then we will replace each group by the corresponding octal digit. So let's say we have a binary number 100101, and we want to find the equivalent octal number. So first, starting from the LSB, let us make the group of 3 bits, and then let us replace each group by the corresponding octal digit. So here these 100 corresponds to 4, and likewise these 101 corresponds to 5. That means for the given binary number, the equivalent octal number is equal to 45. So let's take one more example, which also contains the fractional part. So let's say we want to find the equivalent octal number of the given binary number. So starting from this binary point, let us make the group of 3 bits both on the left and the right-hand side. So on the left-hand side of this binary point, the first group is 011, and the next group is 111. Likewise, the third group is 100, and the fourth group is 001. So here, to make a group of 3 bits, 2 more zeros are added over here similarly after this binary point. The first group is 010, and the second group is 100. So over here also, to make a group of 3 bits, 2 more zeros are added at the end. So now this 001 corresponds to 1 in the octal number system. Likewise, this 100 corresponds to 4. Similarly, this 111 corresponds to 7, while this 011 corresponds to 3. The equivalent octal number is equal to 147324. So in this way we can convert any binary number into the equivalent octal number. Hexadecimal number system. All right, so similarly now let us understand about this hexadecimal number system and counting in hex number system. So as I said earlier, this hexadecimal number system is a base 16 number system, and it consists of total 16 symbols, and here is the list of all 16 symbols. So if we compare this system with the decimal number system, then the 0 to 9 in the hexadecimal number system is same as the decimal number system. But the 10 in the decimal corresponds to A in the hexadecimal number system. Likewise, this 11 in the decimal number system corresponds to B in this hexadecimal number system. And likewise this 12 corresponds to C. And this 13 corresponds to D. Similarly, this 14 and 15 in the decimal number system corresponds to E and F in this hexadecimal number system. So that is all the 16 symbols of this hexadecimal number system. So if you want to count further, then we will reset that column to the 0, and we will increment the next column by the 1. That means after the F, the next number in the counting is equal to 10. That means the 16 in the decimal number system corresponds to 10 in this hexadecimal number system, and if we continue the counting, then we can go up to 1F. So once again, in this rightmost column, we have used all the symbols of that particular number system. That means after that we can reset that column to the 0, and we can increment the next column by 1. That means after 1F the next number will be equal to 20, and then after the counting will go on. So that is how we can count in this hexadecimal number system. And here is a list of numbers 0 to 15 in the octal, hexadecimal, and the binary number system. Hexadecimal to binary conversion. So now let's see how to convert any hexadecimal number into the corresponding binary equivalent number. So for this hexadecimal to binary conversion, we will replace each hexadecimal digit by the equivalent 4-bit binary number. So let's say we want to convert this hexadecimal number into the corresponding binary number. So first of all, we will replace each hexadecimal digit by the corresponding 4-bit binary number. So here this 1 corresponds to 0001, while this C corresponds to 1100, likewise this F corresponds to 1111, while these 3 corresponds to 0011. So if we combine all these binary groups, then this is the binary equivalent number of the given hex number. So let us take one more example, which also includes the fractional part. So let's say we want to convert this hex number into the binary equivalent number. So first of all, let us replace each hex digit by the equivalent 4-bit binary number. So these are the equivalent 4-bit of binary numbers of the given hex digits. And if we combine all these binary groups, and this is the binary equivalent number of the given hex number. So that is how we can convert any hexadecimal number into the binary equivalent number. Binary to hexadecimal conversion. So similarly, now let's see the binary to hexadecimal conversion. So for the binary to hexadecimal conversion, starting from the LSB, we will make the group of 4 bits, and then we will replace each group by the corresponding hex digit. So let's say we have this binary number, and we want to convert it into the equivalent hexadecimal number. So first of all, starting from the LSB, let's make the group of 4 bits. So here the 1 group is 1101, and to make the second group here, we will add 1 more 0. That means the second group is 0110, so this 0110 corresponds to 6, while this 1101 corresponds to D. That means for the given binary number the equivalent hex number is equal to 6D. So let us take one more example. So let's say we want to find the equivalent hex number of the given binary number. So first of all, starting from the binary point, let us make the group of 4 on the both sides. So on the left-hand side, the first group is 1011, and the next group is 0011. Likewise, the third group is also 0011. Similarly, on the right-hand side of this binary point, the 4-bit group is 0101. So now this 0011 corresponds to 3, while this 0011 also corresponds to 3. Then this 1011 corresponds to B, while this 0101 corresponds. So that is how we can convert any binary number into the equivalent hexadecimal number. Alright, so now let us see how to convert any octal, or the hexadecimal number, into the decimal equivalent number. Octal to decimal conversion. And first let us see the octal to decimal conversion. So in the earlier videos, we have seen that if we have any number in the base B number system, then this is how we can convert it into the equivalent decimal number. So here this B corresponds to the base of that particular number system. So suppose if we have a number in the octal number system, then this is how it can be converted into the decimal number. So here this least significant digit has the weightage of 1. And as we move towards the right, then the weightage of each digit will increase by the factor of 8. So if we just add all these terms, then we will get the equivalent decimal number. So let's say we have some octal number 4126, and we want to find its equivalent decimal number. So for that, let us write down each digit with their corresponding weight, and then let us add them all. So here, this 6 into 8 to the power 0 is equal to 6. Then this 2 times 8 to the power 1 is equal to 16. Likewise, this 1 times a to the power 2 is 64. While this 4 times 8 to the power 3 is equal to 2048. So if you do the summation of all these numbers, then it is equal to 2134. That means the decimal equivalent of the given octal number is equal to 2134. Now suppose we have a fractional part, then for the fractional part, also the procedure will remain the same. So after this octal point, as we move towards the right, then the weightage of each digit will reduce by the factor of 8. So here the initial 4 digits are same, as we have seen their summation is equal to 2134. So after this octal point, these 1 by 8 corresponds to 0.125, while this 7 times 8 to the power 2 corresponds to 0.109. So if we add all these terms, then their summation is equal to 2134. 234. So that is the decimal equivalent of the given octal number. So in this way we can perform the octal to decimal conversion, hexadecimal to decimal conversion. And similarly, we can also do the hexadecimal to the decimal conversion. But in this case, the weightage of each digit will increase or reduce by the factor of 16. So let's say we want to find the decimal equivalent of the given hex number. So starting from the hexadecimal point, as we move towards the left, then the weightage of each digit will increase by the factor of 16. And as we move towards the right from this hexadecimal point, then the weightage of each digit will reduce by the factor of 16. So here these D corresponds to 13, while this B corresponds to 11. So if we add all these terms, then their summation is equal to 29090,379. So that is the decimal equivalent of the given hex number. So in this way, we can convert any hexadecimal number into the decimal equivalent number. All right, so far we understood that how to find the decimal equivalent of the given octal, or the hexadecimal number. Decimal to octal conversion. So similarly, now let us see, suppose we have been given some decimal number, and how to convert it into the equivalent octal, or the hexadecimal number, and first of all let us see this decimal to octal conversion. So during the decimal to binary conversion, we have seen that by successfully dividing this decimal number by the 2, we can get the binary equivalent number. So similarly, for the decimal to octal conversion, we will successfully divide the decimal number by the 8. So let's say we want to convert this decimal number 120 into the octal number, so for that let us divide this number by the 8. So after the first division the quotient will be equal to 15, while the remainder is equal to 0. Similarly, when the second time we divide this number by the 8 and the quotient is equal to 1 and the remainder is equal to 7, now once again, if you try to divide this number by 8, then we cannot divide it. That means the quotient is equal to 0 and the remainder is equal to 1, and if we write down all these remainders from top to bottom, then we will get our octal equivalent of the given decimal number, that is equal to 170. Now suppose the decimal number also contains some fractional part, then we will treat the integer and the fractional part separately. So for the integer part, by following the same procedure, we can find the equivalent octal number, while for this decimal fractional part, by successfully multiplying it by the factor of 8, we can find the equivalent octal number. So first time, if you multiply this 0.5 by 8, then after the multiplication the number is equal to 3.6. So from this 3.6, this 3 is the integer part, while the 0.6 is the fractional part. So let us write down this integer part separately. So once again, if we multiply this 0.6 by the 8, then after the multiplication the number is equal to 4.8. So once again, let us write down this 4 separately, and let us multiply this fractional part by 8. So if we follow the same procedure for a couple of times, then these are the integer parts, so let us write down this integer parts from top to bottom, and in fact it is the equivalent octal number of the 0. 45, that means for the given decimal number the equivalent octal number is equal to 170. 3463. So that is how we can convert any decimal number into the equivalent octal number. Decimal to hexadecimal conversion. All right, so similarly now let us see the decimal to hexadecimal conversion. So let's say we want to convert this decimal number into the equivalent hex number, so as I said, we will consider the integer and the fractional parts separately. So for the integer part, by successively dividing this number by the 16, we can find the equivalent hex number. That means if we divide this 275 by 16, then the quotient is equal to 17, and the remainder is equal to 3. So once again, if we divide it by the 16, then the quotient is 1, and the remainder is also 1. Now if we try to divide this 1 by 16, then we cannot divide it. That means now the quotient is 0, while the remainder is equal to 1, and if we write down this remainders from bottom to top, then we will get our equivalent hex number, that is equal to 113. So in this way, for the integer part, we got the equivalent hex number. Similarly, let us find out the hex number for the fractional part. So for this fractional part, we will successfully multiply this fractional part by 16. So for the first time, when we multiplied by 16, then after the multiplication the number is equal to 5.28. So let us write down this integer part separately, and let us multiply this fractional part once again. So after the multiplication the number is equal to 4.48. So once again, let us write down this integer part separately, and if you follow the same procedure for a couple of times, then these are the integer numbers, and here this 10 corresponds to a in the hexadecimal number system. So if we write down all these integers from top to bottom, then we will get our equivalent hex number, that is equal to 0. 547A, that means the equivalent hexadecimal number for the given decimal number is equal to 113. So in this way, we can convert any decimal number into the equivalent hex number. Now so far we have seen the following conversions. So the only thing which remains is the octal to hex, and the hex to octal conversion. Octal to hexadecimal conversion. And first, let us see how to convert any octal number into the equivalent hex number. So it is very simple. So first convert the octal number into the equivalent binary number, and then convert this binary number into the equivalent hex number. So let us take one example. So let's say we want to convert this octal number into the equivalent hex number. So first of all, we will find its equivalent binary number, and for that we will replace each octal digit by the equivalent 3-bit binary number. So these are the equivalent binary numbers for the given octal digits. So if we combine all these binary groups, then this is the equivalent binary number of the given octal number. Now for the binary to hex conversion, starting from the LSB, we will make a group of 4 bits. So here, just to make a group of 4, one more 0 is added over here. And now let us replace each group by the corresponding hex digit. So this 0101 corresponds to 5, while this 1111 corresponds to F. That means for the given octal number the equivalent hex number is equal to 5. So that is how we can perform the octal to hexadecimal conversion. And similarly, we can also convert any hex number into the equivalent octal number. Hexadecimal to octal conversion. So for that, first of all, we will convert the hex number into the equivalent binary number, and then we will convert this binary number into the equivalent octal number. So let us take one example. So let's say we want to convert this hex number into the equivalent octal number. So first of all, let us convert this hex number into the binary number, and for that we will replace each hex digit with the corresponding 4-bit binary number. So if we combine all these binary groups, then this is the equivalent binary number of the given hex number. Now to perform the binary to octal conversion, starting from the LSB, let us make the group of 3 bits, and let us replace each group by the corresponding octal digit. That means for the given hex number the equivalent octal number is equal to 2716. So that is how we can convert any hex number into the equivalent octal number. So I hope in this video you understood about this octal and the hexadecimal number system, and you also understood how to convert any number from one number system to the other number system. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.